Welcome, Math 13 students. I'm going to complete my review of exam number 3 tonight. I'm going to work through examples from 8.2, 8.3, and then 10.1 and 10.2. So, yesterday, when we left off, the last thing I mentioned was the 5-step process for the hypothesis test when we use the p-value approach. That's exactly where I'm going to begin tonight. You've seen me do the list a number of times, so I'm really not sure how much reading I really need to do here. But basically, write the claim, find the p-value, do the comparison, determine the outcome, and then address that initial claim. And that's really the way it works. From here on out, anytime we do a hypothesis test anywhere in the world, the big boys and girls use the same method. They leave out some of the steps because they're pros, but it's really the same process. So here's a claim. More than 60% of students take statistics, at least at Heart Math. We're going to test this claim with a level of significance of 5%. And we have some data. That's an x equals, and n equals, n is equal to 200. We're going to go with 100 and 130 out of 200. Say yes. I will take statistics. Thank you. In fact, I'll take it this semester. So there's the data. How do we address the claim? You see me do this a number of times before, and remember, the keystrokes are also in your text and also on the Canvas course shell. So translate and identify first. More than 60%. That's an alternative hypothesis. P is greater than 60%. All right, so I now know I have a right tail test. The initial claim is the alternative hypothesis. 60%. P is greater than 60%. So there's step number one. Let me go ahead and share my screen, and we'll take care of step number 2. There you are. Please. All right, so stat over to test. I will remind you, it's the one prop Z test. My initial claim was 0.60. 60%. We had 130 out of 200, and we had a right tail test greater than. We'll go ahead and hit calculate, and I've got a p-value of 0.0744 and change. The p-value is a probability, so I want 3 significant digits, 0.0745. Let me unmute, or excuse me, I am unmuted. Let me stop sharing. Sounds so bad. All right, so P is equal to 0.0745. 0.0745, there's my level of significance, 0.05. I will note that my level of significance is less than my p-value. P-value is bigger than my level of significance. So that means we will fail to reject our null hypothesis. So my initial claim was that guy right there, the alternative hypothesis, but I was unable to reject the null hypothesis. So at alpha equals 0.05 or 5%, data do not support P being greater than 60%, the population proportion being greater than 60%. And you will note we have those 5 steps. Now, I want to do one more thing with this problem. The level of significance here was 5%. Suppose we change that level of significance to 10%. So, if alpha equals 10%, so 4, 0.0745, 0.0, oh, excuse me, step number 30, 0.0. Oh, I gotta do that again, that's too messy. Can't erase Sharpies. So now alpha is equal to 10%. Step number 3, 0.0745, 0.10. If I've changed my level of significance, that might change my interpretation of the outcome of the test. So now we will reject H naught. And in this case, data now support P being greater than 60%. That's when we switched from a 5% to a 10% level of significance. We're more likely to make a type 1 error here. But it's easier to reject the null hypothesis. That's kind of like the price you pay. So remember that alpha is something that the researcher brings to the question. It is not preordained what it should be. In fact, many times there is no alpha. We just report p-values being less than this, that, or the other value. So we're now ready to go ahead and move into section 8.2, or excuse me, 8.3, where we have claims about a mean. All right. There are 2 versions of this type of claim that we encounter here in 8.3. The one where we work with summary statistics and the one where we work with data. You've seen me do some of each. I'm just going to do the one with stats. So we have a claim. Mean number of units taken by students here at Hartnell is 12.5 units. Oh, by the way, that's per semester. All right. It's probably a little high, but I'm making the problem up as I go along. Do we have data? Sure we do. X bar equals 13.2. S equals 4.3. These are units, by the way, for a semester. I'm kind of a stickler when it comes to units. This really helps me keep stuff straight. Sample size. Yeah, let's go with 200 again. All right. Now, the first question I could possibly ask you on this type of question here, are the requirements met? For the requirements to be met, we need a simple random sample. By the way, I need to point that out. This is a simple random sample. I do point this out on all problems in exams and quizzes. And because it is a simple random sample, And because we have n greater than 30 as required, the requirements for a claim are met, and I can go ahead and start to crunch the numbers. So let's see, contrasting color. Mean number of units is 12.5 units. That is a claim that is as equal as equality comes. That tells me that my alternative hypothesis, when I do get to writing it on my fresh sheet of paper, will be the not equal to, because that's the alternative to equal to. It should say mu equals. There we go. So we're going to use what do we want to use here? I'm going to use another 5% level of significance. It's a very common one to use. In fact, our text may even say if there's no level of significance, go ahead and use 5%. Do note, though, I try to spell that out explicitly during our quizzes and exams. So H naught mu equals 12.5 units a semester. The alternative, mu is not equal to that. I'll go ahead and find my p-value, compare it to my alpha of 5%. We use t-test here. You've seen me do this a number of times, but let me run through the keystrokes again. There we go. So, stat test, t-test. I have statistics. My null claim was 12.5 units per semester. My data said I had 13.2 units per semester with a standard deviation of 4.3 units per semester. We had a sample size of 200 again, I believe, yes. And this was a two-tailed test. So there's my p-value, 0.022352224, 0.0224. All right, so less than. So we are going to reject our null hypothesis. So at alpha equals 5%, data do not support mu equal to 12.5 units per semester. So there we go. The 5 steps, the p-value approach. As I say, this really truly does not change in terms of the basic recipe. And you can count on problems like this on quizzes and exams and finals. So there we go. That's really what I want to say about chapter 8. Chapter 10 also requires a nice example. And this is where we remember that chapter 10 focused on correlation and regression. These are very identifiable problems. We have XY data. We test for correlation. We test for regression. Let's see, I'm going to keep my problem fairly straightforward because we've seen a bunch of these already. So let's see, 6, 12, 17, 29, 31, and 42. Down below, we have got 93, 91, 87, 80, 51, and 43. So I have no idea what we're measuring. It's a very off-the-cuff problem, but we are going to do several things. We are going to construct a scatter plot. We are going to test for correlation. And depending on what well, regardless of what we find, we're going to find the regression equation, and then we shall use it. So those are the things we're going to do with this data set. Chapter 10 is a very, very, very calculator heavy piece of arithmetic. So let me go ahead and share my screen. You're going to have to watch me go ahead and enter in my data. Stat to edit. We need 2 free lists. And 6, 12, 17. 29, 31, 42. And again, I don't go overboard when it comes to data sets in terms of size. I really believe it's more about the statistics that we do than the number of numbers we push around. So there we go. What do we do there? Second, stat plot. Make sure my scatter plot is turned on. We are focused on list 1 and list 2. And I cannot say this enough, which is why I like to do this problem so many times during this bit of detail here. Zoom. Zoom stat. Your calculator truly wishes to help. And there we go. And we can identify a reasonably linear negative correlation there. Would have a slope of some sort of negative value. That's good. Now I can go ahead and consider my test. Before I do that, I'm going to go ahead and note we've done the scatter plot, and then we're going to test for correlation. So let me get that set up. I will remind you, correlation is when we get to reject the null hypothesis. It is about the population correlation coefficient rho. 0 means there's no correlation, and we should just walk away from the data. The alternative hypothesis, which is the initial claim, tells me that there is a reasonable correlation between X and Y, and with a reasonable appreciation of probability, I can use my X to estimate probable outcomes for Y. P equals. I realize I didn't say alpha. I'm going to use another 5%. So, linear regression t-test is where we take care of our data. Crunching, it's down near the bottom because we're almost out of semester. There, no, one more. There it is. List 1, list 2. In fact, I already have the two-tailed test selected. Very important there. You'll get a wrong p-value if you select the wrong type of test. We'll calculate that, and I got a p-value of 0.0122. So, on share 0.0122, 0.05. Ooh, less than. We get to reject H naught and to go through all the tedious steps at alpha equals 5%. data support row not being equal to 0. And that's what it means, or that's what we need, I should say, to make sure we are on firm ground when we reach for our regression equation and begin to make some sort of prediction. So we are now going to go ahead and find the regression equation. That's the y hat equals b naught plus b1x. So, and remember, this is the section that truly, or I should say the chapter that truly hangs together very well, because we've already done the hard work. We've already got the a plus bx right up here. Slight change in notation, nothing to freak out about. 107.5. I'm going to take one decimal place. That's the y-intercept minus 1.5x. So I now have my regression equation, and I'm going to use that when x equals exactly 100. So the predicted y value is 107.5 minus 1.5 times 100. And my calculator, let me just switch back one last time. It's such a simple calculation. 107.5 minus 1.5 times 100. And we get a negative 42.5. And it's not really part of what I'm going to ask you guys to do, but I will point this out, that if I go back to my graph, yes, I have a place for y equals. I can put in the equation, and I could put in that one that we just found with the rounded values, or vars statistics. Ooh, over to equation. There's my regression equation. All the ugly decimal places. And there we go. And it falls right in there. And at that point, I could maybe plug in x equals 100 or whatever. But that's the way the whole thing plays out. Will I ask you to do that on a quiz or an exam? No, it's a little too hands-on for something like an online class. But it's very, very doable. I now have a way to evaluate that. And there we go. So that really brings me to the end of my review for exam number 3. You've seen detail on chapter 7, chapter 8, and chapter 10. It's available through late PM tonight. If there is any issue with any of the graphics downloading, and I think it's pretty graphics light, by the way, just shoot me an email, and don't stress about it. No one's been dinged negatively in any way, shape, or form for video that doesn't download. All right, I'm going to stop the recording.